Neat test 10 physics paper solution. Question number 1. According to Bohr theory of the hydrogen atom, the total energy of the hydrogen atom when its electron revolving in the nth orbit, stationary orbit, is so energy is directly proportional to z square by n square, inversely proportional to n square. Option D. The shortest wavelength of the spectrum for the transition of an electron to shortest wavelength means wavelength is minimum, so energy is maximum. So from infinity to n is equal to 4 of hydrogen like atom is the same as the shortest wavelength. यहाँ पे इसका z, and for hydrogen atom shortest wavelength of the Balmer series. So n is equal to 2, r equal. So energy z square 1 by n square is equal to 1 by 2 square. 4 and 4. Z square is equal to 4, Z is equal to 2. Option A. Question number 3. Electron in hydrogen atom makes and transition from an excited state to the ground state. Which of the following statement is true? Its kinetic energy increases. Kinetic energy half mv orbital speed square. Orbital speed v naught square क्या हुआ? ग्रेविटेशन चैप्टर याद है, gm by r इनवर्सली प्रोपोर्शनल टू आर. यहाँ ग्रेविटेशन नहीं होगा बट कूलोम फोर्स में भी इनवर्सली प्रोपोर्शनल टू अंडर रूट आर. So as we decrease radius, orbital velocity will increase, kinetic velocity will increase. और ऐसा कुछ याद के Q1 Q2 by 2R kinetic energy inversely proportional to R. So kinetic energy will increase and total energy will decrease as it moves closer to nucleus. Total energy will decrease, potential and total. Option A. Question 4. In the Bohr model, hydrogen atom, the ratio of kinetic energy to total energy. Kinetic energy is Kq1 Q2 by 2R and total energy is minus Kq1 Q2 by 2R. Ratio is -1. Option A. Question 5. According to Bohr's theory of the hydrogen atom, the speed of the electron be proportional to z by n. Option C. Question number 6. If elements with principal quantum number n greater than 4 were not allowed, means maximum value of n can be 4, then total number of electron in that atom or number of proton is 2n square. Wait. In first orbit, number of electron 2, second 8, then 18. Wait, 18. Third and fourth में 32. Total number of electron 10 and this is 50. Total number of electrons 60. So we can make 60 different types of atom. Option A. Question number 7. Energy levels A, B, C of this certain atom corresponding to increasing value of energy. Okay. This is lambda 1, lambda 2, and lambda 3. E3 is equal to E1 plus E2. This plus this is equal to this energy. And E is equal to Hc by lambda. Hc by lambda 3 is equal to Hc by lambda 1 plus Hc by lambda 2. 1 by lambda 3, option B. Question number 8. The energy required to extract A hydrogen atom from 1 to 2 energy state is 10.2 electron. What is the wavelength of the radiation emitted? Okay, lambda is equal to 12,400 upon energy in electron volt. This answer is in angstrom. 12,400 upon E is 10.2. Approximate answer is 12. 9. Ionization energy of hydrogen atom in the ground state is E. What is the ionization energy of lithium atom in the second excited state? So ionization energy 13.6 Z square by N square. For hydrogen atom, 13.6 is equal to E. For lithium, 13.6 Z is 3. So 3 square. And second excited state is also N is equal to 3. Same as hydrogen, E. 10. An orbital electron in ground state of hydrogen has an angular momentum L1. Angular momentum mvr is equal to nh upon 2 pi. It depends only on orbit number or main quantum number. So both are in first orbit. So L1 is equal to L2. Option A. 11. A photoelectric current in a photoelectric cell depends nature of the metal, the wavelength of the incident, intensity, all of the above. Option B. In a photoelectric experiment, two metal plates A and B are used for a given intensity. Work function is more than that A. So EV naught is equal to H nu minus H nu naught. This is work function. So if we draw graph between V naught and nu, slope is H by E, constant for both the metals. So slope is constant. Option A is correct. And threshold frequency mu naught depends on work function. Work function of metal B is more. So this line is for B, this is for A. Option A. 13. Moving with the same velocity, which of the following has the longest de Broglie wavelength? De Broglie wavelength is h by P or h by mv. Velocity is same, so it depends on mass, inversely proportional to mass. Minimum mass, for minimum mass, lambda is maximum. Beta particle means electron mass is minimum, so lambda is maximum. Option A. 14. Two photons having, okay, if momentum is lambda is equal to h by p, lambda is a scalar quantity. So if momentum is same, definitely we will get same lambda. But if momentum is same, then lambda is same. But p is equal to h by lambda. If wavelength is same, then magnitude of wavelength, a magnitude of momentum will be same, but direction can be different. So option D. In photoelectric effect, when photons of energy h nu falls on the direct formula, the ejected electron have a distribution of maximum kinetic energy is equal to h nu minus h nu naught. This is maximum, and energy of these electrons are between 0 to this maximum energy. Option B. 16. Photoelectric effect can be explained by assuming that light is a particle consist of quanta. Option D. 17. If nr and nb be the respectively the number of photons emitted per second by the red bulb and blue bulb, equal power. Power is equal, so E red by time is equal to E blue by time. And number of photons of red per unit time H C by lambda R is equal to N B by T H C by lambda V. Okay, N R by H lambda R is constant. N by lambda is constant. So longer wavelength number of photons are large. NR is greater than NB. Time to run alone. 80. When monochromatic light of wavelength lambda illuminates a metal surface, then stopping potential for photoelectric current is 3 V naught. So 3 EV naught is equal to H wavelength is lambda minus 5. If wavelength changes to 2 lambda, stopping potential become V naught. So 3 EV naught is equal to Hc by 2 lambda minus 5. Threshold wavelength for the photoelectric emission. This is Hc by lambda naught. Hc by lambda naught. Divide this equation. After solving this equation, we will get lambda naught is 4 lambda. Option A. 19. Aluminium plus neutron is equal to sodium plus, okay. Total number of nucleons. Left hand side 13 and the right hand side we get 13. So 11 plus 2. And mass number 27 plus 1, 28. And right hand side 24. So yeah, X is 2He4. Helium nucleus, alpha particle. D. 20. The mean density of nuclei is proportional to it is constant. So none of the above. 21. Radioactive decay of element A, X, Z, A, Y, Z plus 1, A minus 4, K, Z minus 1, A minus 4, K. Here Z is increasing, so here beta particle is emitted. Here Z is decreasing and A is decreased by 4, so alpha particle. And here there is no change in Z and A, so gamma particle. Beta, alpha, gamma. Option B. 22. Figure shows a roughly approximated curve of binding energy per nucleon with mass number W, X, Y, and Z are four nuclei indicated on the curve. According to this curve, the process that would release energy is so process which creates stable nuclei will emit energy. So Y 2Z. Z is unstable, so it will not emit any energy. It will not emit any. W X plus Z. X is more stable, but Z is less stable than W. So it will also not emit any. W 2Y. Y is more stable than W, so it will emit energy. Option C. 23. The binding energy, okay, equation 2. Binding energy per nucleon of deuteron is 1.15 and number of nucleons are 4. So total binding energy left hand side is 4.6. This side 4 into 7.1, 28.4. Total energy difference is 23.8. Option C. 24. ओके ग्राफ को ठीक से देखो. If value of any signal is 1, then output is 1. If all are 0, then output is 0. This is an OR circuit, option C. 25. Forward bias. In forward bias, P is at higher potential and N is at lower potential. First, P is at lower potential, it is in reverse bias. Second, low reverse bias. Third, P is at higher potential. So C is in forward bias. 26. When an impurity is locked into an intrinsic semiconductor, the conductivity of semiconductor will increase. A. 27. In the figure, potential difference between A and B. This 10 and 10 are in series, so net resistance is 5 and this is 10. 10 and 5. So this will have 10 volt, this is 5 ohm, this is 10 ohm, and this resistance will have 20 volt. Total voltage is 30 ohm. So voltage across AB is 10 volt. Current is same, voltage is directly proportional to resistance, half resistance, half voltage. 28. When a battery is connected to a p-type semiconductor with a metallic wire, the current in the semiconductor is p-type. So current is mainly due to holes inside the metallic wire is due to electrons, and inside the battery is due to ions. Option A. 29. When a silicon PN junction is in forward bias condition, series resistance, it has a knee voltage 0.6 volt. Current flow it is 5 milliampere. When PN junction is connected to a 2.6 volt, this knee voltage is 0.6 volt. Current is 5 milliampere. The voltage across this resistance is 2 volt is equal to IR. R is 2 divided by 5, 400 ohm. Option C. 30. In a pure silicon, Ni is 10 raised to 16 per meter cube. At 300 Kelvin, 10 raised to 21 atoms of phosphorus. Phosphorus means pentavalent impurity. So Ne is 10 raised to 21. And from mass exchange law, NeNH is equal to Ni square. NH is Ni square by Ne. 10 raised to 32 by 10 raised to 21. 10 raised to 11. Option C. 31. In the following circuit, find I1 and I2. Well, 14, 2. Okay. In ideal condition, resistance of this PN diode is in forward bias 0. So this resistance becomes short circuited, and this is also short circuited. So final circuit is battery and only one resistance, 2 kilo ohm. And if this circuit is short circuited, then this I1 becomes 0. Current will pass through this wire. I1 is 0 and I2 is 10 divided by 2 kilo ohm, 5 milliampere. So I1 is 0, I2 is 5 milliampere. Option D. Question number 32. Wx, Wy. Output of this OR gate is W plus X. and this is W plus Y, and this is AND gate. So W plus X dot W plus Y open this W into W plus Y plus X into W plus Y. W plus WY WX plus XY 1 plus this EW plus X. Option C 33. This is only possible. This is OR operation. This is only possible when both the terms are equal to 0. And if both the terms are equal to 0 means A and B both are equal to 1. 1 dot 1 is 1, 1 dot 0, U is 0. So A and B both are equal to 1. Option D 34. Which of the following is incorrect? Forbidden energy gap is the energy gap between the valence band. Okay, which of the following is correct? Forbidden energy gap is the energy gap between the valence band and conduction band. Correct. Forbidden energy gap may be empty or may be partially. No, B is wrong. C, no electron will exist in the forbidden energy gap. Correct. Both A and C are correct. B. 35. The drift current in a PN junction. In a PN junction, diffusion current is from P to N and drift current is from N to P. Option A. 36. Find current through Zener diode. Okay, voltage across this 1 kilo ohm is 5 volts. So current in this is 5 by 1000, 5 milliampere. And voltage across this point is 5 volt, then remaining voltage is 20 volt. Then current in this wire is 10 milliampere. The 5 milliampere is going in this resistance. Then remaining 5 ampere will go through this Zener diode. So answer is 5 milliampere. 37. Okay, positive cycle will pass through this and it equally divides on both the resistance. So across this resistance we will get only half of the input. So answer is C. 38. A heavy nucleus is unstable for any value of n by p because electrostatic repulsion. Number of protons will increase, so electrostatic repulsion dominates over nuclear attraction. Option A correct. 39. In a nuclear fusion reaction, if the energy is released, then binding energy of products are more stable. So binding energy of products are more than binding energy of reactants. Question number 40. A nucleus at rest breaks into two nuclear parts, which have their velocities v1 by v2 is 2:1. M1 from angular momentum conservation. M1 v1 is M2 v2. So M1 by M2 is v2 by v1 is 1 by 2. And M is directly proportional to R cube, density in 2 volume. So R1 cube by R2 cube. R1 by R2 is 1 by 2. Option B. Two identical metal plates show photoelectric effect by light wave of lambda A falling on the plate A and lambda B on plate B. Lambda A is twice of lambda B. Lambda A is 2 times of lambda B. So energy of B, incident energy, is 2 times of energy is inversely proportional to lambda. And if energy is twice work functions are same, then kinetic energy in case of B is more than 2 times of kinetic energy of A. Option B, 42. Assess an p-type semiconductor is positive type crystal. No, it is a neutral crystal. Assertion is wrong. Reason a p-type semiconductor is an uncharged crystal. Correct. Assertion is incorrect. Reason is correct. Option D. 43. Hydrogen atom consists of only one electron, but its emission spectrum has many lines. करेक्ट है. एमिशन स्पेक्ट्रम कैसे बनेगा? ग्राउंड स्टेट से इलेक्ट्रॉन विल एक्साइट, इट कैन एक्साइटेड टू n is equal to 2, 3 or 4, and during emission, if electron is coming from higher energy to lower energy, its path can be from n2 to n1. There can be many possibilities, so number of spectrum lines are more many. And reason one, Lyman series is found in absorption spectrum. In absorption spectrum, electron will always excited from the ground state, so n is constant, so it will always give Lyman series. Both are correct, but reason is not explaining accession completely, so B is correct. 44. In a photoelectric experiment, for C and B saturation current is constant, so intensities are same. And for A and B stopping potential is same. Option A and B will have different intensities. Correct? A and B have different intensities, while B and C will have different frequencies. B and C stopping potentials are different, so stopping stopping potentials are different, so frequencies will also different. Option A is correct. 45. Direct formula: lambda is equal to h by p or h by under root 2 me, and energies for charged particle energy is qv. Option C.